Hello everyone, welcome to the another lecture of Elements, Compound, Symbols and Formula, Class 6. Myself, Suman Singh. So in the class we have discussed about atoms and molecules, right? So now in this class we will discuss about the formula. Okay. So what is this formula? First of all, as we have seen, suppose we are talking about sodium chloride. Okay, sodium chloride. So how we will write in a short form? We used to write NaCl, right? So this NaCl is what? It is the formula of sodium chloride. Okay, so just it is a here example. I will discuss in detail about this. So as we know that molecules of an element or a compound can be represented by a formula, right? And formula is what? Which is a accepted universally all over the world. Means what? Molecules or a compound can be represented by a formula, okay, and that formula is accepted universally all over the world. Okay, so what is this formula? How we can define this? We can define like this: a formula, plural form is formulae, is a short way of representing the molecules of the element or a compound. Okay, this is just like this. If we are talking about the I will give you one example. If we talk about sodium chloride, so sodium chloride we used to write in a short form NaCl. Okay, now again, for water we used to write H2O. Okay, for carbon dioxide we used to write CO2, like this. So this is what CO2, NaCl, H2O, these are what? This is the formula. So what is the formula? Formula is just a short way of representing the molecules of an element or a compound, right? So I hope you have got some idea about the formula. Now next is some of the example is given here. As you can see here, formula, what is the need of this formula? Why we have invented formula? So just the need is very simple. Need is this. Okay, formula, if you are writing for anything, it just save our time. Okay, it saves the space. Okay, and it saves the energy. That is why we are using here formula. This is the simple three uses of formula. Because I will take you I will give you one example. Suppose when we are writing here WATER, how many letters is there? 1, 2, 3, 4, 5. 5 letters, and it took time and energy, right? But for water, we can write short form H2O. How it is what? And only in 3 words we can define water, right? So it also saves our time, it also saves our space, and it also saves our energy, right? One more example, let me tell you. Suppose we are writing SODIUM CHLORIDE, sodium chloride, right? This means how many letters are there? So many letters are there, right? So for this, so many time is required to write this, right? So what we will do, we will write in a short form as like NaCl. Just in 4 words we can represent this, right? Entire such a big thing we can represent in a short form here like this, right? So it is saving our time, right? First, and secondly, it is saving the space. You see, for writing sodium chloride, so many space is required, but it has saved the space also. Now energy, for writing this we used to require energy, so it also save our energy also. Okay, so I hope you have understood what is the need of this formula. Now, formula of an element. When we talk about the formula of an element, in case of an element, each molecule is made up of a definite number of atoms, right? When we talk about the element, every element is made up of some numbers of element, some numbers of atom. Okay, just like this, when we are writing H2, it is made up of 2 hydrogen atom. Okay, it is made up of 2 hydrogen atom. Okay, so in this way, when we talk about in case of element, each molecules is made up of what? Definite number of atom, right? And the number of atom in a molecule of an element is called what? Atomicity. Okay, the number of an element in a molecule of an element is called what? Atomicity. Let me explain you like this. Suppose this is NaCl. So how many atoms are there? 2. So its atomicity is 2, right? Now again, some of the example is given here. We will discuss about this. Now, when we talk about the atomicity, so this atomicity we can divide in a following way. One is what? Monoatomic elements means when we talk about the elements they are molecules can be divided into various types. One is monoatomic molecules or diatomic, okay, or triatomic. As you can see here, triatomic is there, triatomic, and next is polyatomic, as you can see here, right? So we will discuss about this, what is monoatomic, diatomic, and polyatomic. So if any molecule is there and that molecule or an element or a or a molecule, we can say, if it is made up of only one atom, okay, if it is made up of only one atom, then that type of element is called monoatomic elements, okay, or monoatomic molecules, okay. As you can see, helium, only one atom is there, right, in helium. In potassium, only one atom is there, right. In sodium, only one atom is there. In calcium, only one atom is there, right. So these are called what? Monoatomic elements. When the number of element is only one, okay, or we can say number of atom is only one, okay, in a molecule. If the number of atom is only one, if that element is, or if this molecule is made up of only one atom, then it is monoatomic, okay. And if it is made up of two atom, then it will be diatomic. If it is made up of three atom, it will be triatomic. And if it is made up of three or more element, then it will be polyatomic, okay. So as you can see, helium has only one atom here, potassium has only one atom here, here also sodium has only one atom here, and so calcium has only one atom, right? So I hope you have got some idea what is monoatomic. Now again, when we talk about a diatomic, means the molecule is made up of the molecule which contains two atoms, okay. If there are two atoms in a molecule, then it is called what? Diatomic. Example, as you can see, H2 is what? It is a diatomic. O2 is what? It is a diatomic. N2 is what? It is a diatomic. Cl2 is what? It is a diatomic, right? So if the element is made up of two atom, or if the molecules is made up of two atom, then it is called diatomic, okay. As you can see, in H2, two atom of hydrogen, right, H and H. In O2 there are two atom of oxygen, right. In N2 there are two atom of nitrogen. In Cl2 there are two atom of chlorine, right, as you can see. So diatomic means what? If the atom, if the molecule, if a molecule is a diatomic when it contains what? Two atoms, okay. So I hope you have understood this, what? Diatomic, right? Now again, same thing, triatomic. If it is made up of three atom, then it will be triatomic. As you can see, a molecule is a triatomic when it contains three atom, right? For example, O3, right? Now again is next is what? Polyatomic. So when we talk about the polyatomic is what? A molecule is a polyatomic when it contains more than three atom, okay. If it contains more than three atom, then it is called what? Polyatomic. Just in the case of example of phosphorus and sulfur, phosphorus has four atom, right, it is called polyatomic. And sulfur has also eight atoms, right. In S8 there are 8 atoms. In P4 there are 4 atoms. So this type of element, this type of molecule is what is called what? Polyatomic, okay. So I hope you have understood this, right? Now next is formula of a compound. So formula of a compound, when we discuss about this, I will explain you in very simple word, right? What we have seen, compounds are formed by what? Combination of two or more atom, okay, two or more element, okay, two or more than element combine together to form a compound, right? Now one more thing, what we have seen in compound, atoms combined with either whole number, okay. In a compound, when we will see the combinations of atoms in a compound, you will notice that elements, or that atoms, or when we talk about the atoms of that compound, that atoms of that compound is mm, combined together in a whole number, okay. Means what? Suppose this is a compound, right? And in the compound, any compound, so you will see that, suppose we are taking about the NaCl, H2O, or any other example, if you are KCl, right? So you will see that these atoms, the atoms which has combined here, they are in a simple whole number, right? either 1, 2 or 3, right? Because if you talk about this, these are in a 1:1 ratio, okay? Here 2:1 ratio, right? Here 1:1 ratio, right? So in this ratio they are combining. As you can see, it is also written here, atoms combine with each other in a whole number which can be 1, 2 or 3 or more, okay? And this whole number is called what? It is the combining capacity of the element, okay? I hope you have understood this, right? You have understood atoms combine with each other in a whole number, okay? And which can be 1, 2 or 3 or more. And this whole number is called what? Combining capacity of the element, which is also called valency. You will learn in higher class about this, right? So now next is what? For example, here it is given water. Example of water is given, okay? So where do you see water is what? It is a compound, right? And it is made up of hydrogen and oxygen, right? And in that compound you will see that two hydrogen atom is there, okay, and one oxygen atom is there, right? And when they used to combine, they used to form a molecule of water, right? As you can see, water is a compound of hydrogen and oxygen, right? And a two atom of hydrogen combined with an atom of oxygen to form what? Molecule of water, okay? I hope you have understood this, right? Now these are represented by this, as you can see, H2O, this is represented by this. Now therefore what we can say, the whole number ratio in which the hydrogen and oxygen combine, hydrogen and oxygen atoms combine is what? 2:1 ratio, right? H2O means what? Two atom of hydrogen here and one atom of oxygen here, right? It is combined in a 2:1 ratio, okay? This means what? This means that the combining power of the hydrogen is 1 and that of the oxygen is 2, right? So I hope you have understood this. Now there are some formulas are given here, as you can see. I will discuss this in detail one by one. So as you can see, there are some formula of some of the common element like sodium chloride, calcium chloride, magnesium oxide, okay? It is given here. What we have done, first write down the symbol. We have to write down the symbol of that compound, of that element, okay? Of the element side by side they form the compound, okay? Under each conditions, in under each symbols we have to write down the combining power of that element, okay? I will give you example. You will understand with this example. As you can see, when you talk about the sodium and chlorine, the combining power of sodium is what? 1, and the combining power of chlorine is 1. So how we will write? We will write cross multiplication, right? Like this. We will write like this. Na, for Na we will write this. We will write this, the combining power of chlorine, which is 1, and for Cl we will write 1. For because this the two are same, so what we are writing, we are just erasing this one and we are simply writing NaCl, right? Now again, next is when we see the combining power of magnesium is 2 and oxygen is 2, right? So when you will write this, we will write here this, for this we will write this, and for this we will write this. So we will write what? Mg2 and O2, right? So since these two are same, so that is why what we are writing MgO, or this one also you can write, this is not wrong, okay? But just to, since these two are same, that is why we are erasing this one, we are writing MgO, right? In this way, so many examples are given here, as you can see. As first of all, I will give you some of the example. As you can see here, some of the combining power of the different elements are given here. As you can see, for sodium it is given 1 combining power, chlorine for 2 it is given, iron for 2, zinc for 2, aluminum for 3, oxygen for 2, sulfur for 2, chlorine for 1, right? And always remember that this combining power will vary from a compound to compound, okay? So as you can see, some of the example is given. See, for carbon dioxide we used to write CO2, right? And for carbon monoxide we write CO, SO2. As you can see, some of the examples are given here, right? This thing you said we can write on your copy also, right? Now next is, what is the importance of this formula? Okay, so when we talk about the importance of this formula, we will write that first of all is what? They types of element present in the let me start from the beginning. Formula gives us the following information about the compound, okay? What does the formula do? The formula used to give some of the information regarding the compound. Okay, so what is that information? They give the type of element present in the compound. Okay, first of all, which type of element are there in that compound, we can understood from the formula. Okay, next, number of each kind of atom in one molecule of that compound. What is the number of that element or number of the atoms present in that one molecule of that compound, we can identify from there. As you can see, NaCl means there is one atom of sodium and one atom of chlorine. Okay, from here, from this formula you can easily identify this. Now next is ratio of different type of atom present in the molecule. What is the ratio? Suppose CO2, so here 2 1 is to 2 ratio is there, right? So from this ratio also we can identify from this formula. Okay, now next is the very important thing is what? Mass of one molecule of compound. We can easily find out the mass of one molecule of compound from that formula. You will learn this about how to find out the mass in your higher classes, not now. Okay, how to find out the mass from the formula you will learn in higher classes. So some of the example is given. As you can see, the molecule of carbon dioxide gas is represented by CO2. Okay, so it indicates that carbon dioxide molecule is formed by the combination of two elements, which is what? Carbon and oxygen, right? So what we can say, the number of carbon atom is 1 and that of the oxygen is 2, right? So as you can see, the number of carbon atom in is 1, of that oxygen atom is 2, right? In CO2 oxygen is what? 2 and carbon is 1, right? So what we can do, we can find out the mass of one atom of molecule of carbon dioxide can be calculated by adding the mass of one atom of carbon and the mass of another one atom of oxygen. Suppose we have CO2, right? So we have to if we have to find out the mass, we can find out like this: carbon has an atomic mass of 12, right? Plus oxygen has an atomic mass of 16. Let me write here. You will it is not so important, you will just learn in a higher classes. Carbon is 12 and for oxygen we used to write here 16 into 2 will be 32, right? 32 plus 12 it will be, and 32 plus 12 it will become what? 30, 42, right? In this way we used to find out. It is not important for you now, you will learn in this higher classes. Now next is second example. When we see the second example, when we see the second example, when we see the second example, if you write 2CO2 means what? It represents the two molecule of carbon dioxide. Okay, and it contains two atom of carbon and four atom of oxygen. Okay, just what we have to do, we have to multiply. Okay, we multiply the number of atoms of each type, okay, in one molecule by the number written on the left hand side. Okay, so we have to multiply this. Now next is last example is what? The molecule of sulfuric acid is represented by what? H2SO4, right? So in H2SO4 there are two atoms of hydrogen, one atom of sulfur, four atom of oxygen, right? In this way we used to find out. As you can see, it indicates that one molecule of this acid is formed with two atom of hydrogen, one atom of sulfur, four atom of oxygen. They used to combine together to form what? H2SO4, right? So I hope you have understood this, right? So now try to do this exercise. Okay, now in the next class we will discuss about the uses and the uses of different element and the compound on the basis of their properties. Okay, so I hope today you have understood this, right? What is formula and how we have to write this formula, right? So keep up to this. We will discuss and we will keep up to this. In the next class we will discuss about the um, uses of different element and the compound on the basis of their property. Till that, thank you.